The appendix to Chapter 4 is a quick time value of money review. The basic concept of time value of money is that a dollar today is worth more than a dollar in the future. Why? Well, if I had the dollar today, I could invest it and it would earn interest and be worth more in the future. Bird in the hand is true. A dollar in my hand right now is certain. A dollar promised in the future is uncertain. It's risky. So back to the basic concepts of money. More money is better. Sooner is better. Less risky is better. Interest is nothing more than the rent a borrower pays for the use of your money. Simple interest, which we rarely see anymore, just means the interest is always computed based on the original amount. So 5% simple interest on a $100 deposit for 10 years means you earn $5 each year, period. Compound interest is what makes your money grow faster since you earn interest on your interest. 5% compounded annually on a $100 deposit grows each year. So in year one, $100 times 5% is $5. Your total is now $105. Year 2, 105 times 5%. Your new total is $110.25. Year 3, so on. Most of you are probably using the TI Business Analyst too. This is just a generic look at financial calculator keys. N, it's a number of periods. It's not years, it's periods. I is the interest per period. PV is present value. PMT is the payment value used for annuities. FV is future value. CPT is the compute key. And we're going to review all of that. Now we'll look at the TI Business Analyst too, which should look a lot more familiar to you. And there are your TVM keys. Things to remember. Either present value or future value must be negative. And don't forget the sign convention. Inflows to you are positive. Outflows from you are negative. IY is a whole number in your calculator, a decimal in Excel and in formulas. Don't forget, whatever you enter into your calculator register stays there until you clear it or overlay it. So it's important to clear registers before you start a problem. With the 5 TVM keys, you have 2 options. You can enter a value in 4 of the registers, even if one of them is 0, or you can press the second and clear TVM key and it will clear all 5 of them. You want to have your results display a reasonable number of decimal places, and I think 4 is a good choice. To set your calculator to 4, press the second key, press Format, press 4, and press the Enter key. Press the second key and quit, and it'll lock in 4 decimal places. I suspect we're all familiar with the power of spreadsheets, and hopefully you all have basic familiarity with Excel. We'll look at the built-in Excel functions provided to solve TVM problems. There's an Excel function for each of the 5 TVM keys, as they're shown on the slide. You do not have to remember the name of each one or the order of the parameters. Click on the formula icon, f of x. Remember, in Excel, rate is a decimal, not a whole number. The Excel icon will open a spreadsheet with some examples if you need a refresher. We almost always start any presentation on time value of money with future value, since it's so intuitively comfortable. You put your money in a savings account and it grows. That's compounding, and the amount you have at the end is the future value. In this example, you deposit $1,000 in an account paying 8% for 2 years. N is 2, IY is 8, present value is a negative $1,000. Remember, it's an outflow from you. Payment is 0. You aren't adding any dollars to the account over the 2 years. Compute future value to find the future value. In Excel, you'd use the FV function and arrive at the same answer. Again, recall from 331, an annuity is a level stream of equal cash flows at equal intervals. 2 types of annuities. With an ordinary annuity, the cash flows occur at the end of each period. If the cash flows occur at the beginning of each period, it's an annuity due. In the example, you deposit $1,000 at the end of each year for 8 years. The account earns 8%. What's the future value? N is 8, IY is 8, present value is 0. You don't have any money in the account to start with. Payment is minus $1,000. You're depositing the money. Compute future value. For the future value of an annuity, we use the same FV function, but now payment is not 0. Be very careful with the sign convention when you have a non-zero payment. Now to present value. The value today of some value to be received in the future. Example, How much do you have to deposit today in an account earning 8% to have $1,000 in 7 years? N is 7, IY is 8, payment is 0, future value is 1,000, compute present value. The result is negative because it's what you have to deposit to earn $1,000. And in Excel, same function, with payment non-zero. Present value of an annuity. Same logic as with future value. Payment is non-zero. Watch your signs. The example. What's the present value of $50 deposited at the end, ordinary annuity, each year for 5 years if the account earns 8%? N is 5, IY is 8, payment is a minus 50, future value 0, compute present value. And again in Excel, same present value function with a non-zero payment. Now let's review uneven cash flow streams. We move from 5 TVM keys to the cash flow worksheet. First, the 2 cash flow streams shown, one uneven, one an annuity, 5 years, 8%. The long way to find the present value of the uneven stream. Discount each cash flow independently, and in this case manually, by dividing by 1 plus the discount rate raised to the number of years. Sum it up, 193.51. In Excel, the NPV function performs this. But note, it starts with cash flow 1, not cash flow 0. This stream has no cash flow 0, so we're okay using the NPV function kind of as it is. The TI Business Analyst 2 has a built-in cash flow worksheet to perform these calculations. With the cash flow worksheet, it is critical to clear the worksheet before you start. Unless you clear it, it still holds whatever you entered the last time you used it, and it has a lot of cells. To clear it, press CF, then second, and clear work down at the bottom. CF0 will display. Enter the cash flow 0 cash flow, if there is one, and press enter. Pressing enter is critical. If you don't, the value will not be placed in the register. Think of the cash flow worksheet like a column in Excel. You use the up and down arrows to move down to enter more values. Press the down arrow once and it displays the next CF register. Enter that value, press enter, and down again. Now you'll see the FO1, or FON, asking for a frequency. If sequential values in a cash flow stream are equal, then you don't have to enter each one. You can enter the value once and enter a frequency. The default frequency is 1, and you can just press enter to accept the default. Repeat for all the cash flows. Enter and down steps for all cash flows. When all are entered, press NPV. The screen displays I, asking for the discount rate. Enter it, press the down arrow, and compute. NPV will display. Here's an example to walk through if you have gotten rusty on using the cash flow worksheet, just to make sure you can come to the correct answer. In Excel, you got a couple of options. You could use the PV function individually on each cash flow and sum the results. Or you could use the NPV function, both shown on the slide. This ends our TVM review. The following slides are 3 tables from the text. Savings account balance with deposits and withdrawals, interest compounded annually. Same account, but with interest compounded semi-annually. A useful function in your calculator, I-convert, interest conversion. To convert a nominal quoted rate to an equivalent or effective annual rate, or EAR. If a rate is quoted as 5% compounded quarterly, nominal is 5%, enter and down. Compounding per year, number of compounding periods per year is equal to 4. Down to effect and compute. And that ends our Chapter 4A. If you need further review, there are video tutorials posted under Exhibits in Blackboard.